Okay, in section 1.2, we're going to be talking about data, sampling, and variation in data and sampling. Okay, first thing is qualitative versus quantitative. Qualitative data is also known as categorical data. So it describes the qualities, which is the root word for qualitative, quality, of objects of interest. So that's like religion, race, color, zip code, and phone numbers. Now, when you look at quantitative data, it says it's numerical data. So you're dealing with numbers there. But notice over here for the examples, I have a zip code and I have phone numbers, which are numbers, so you would think it would be quantitative, but it's actually qualitative. The way to test this is if the mathematical operations, adding, subtracting, multiplying, dividing, if they don't mean anything. For example, if I take a zip code times another zip code, will that give me a new zip code? Well, no, that's going to be a huge number. That's not going to be a zip code. Same thing for phone numbers. If I take a phone number times another phone number, or divided by another phone number, that's not going to give me a new phone number. That's going to be a huge number. Okay, so that's one way to test it. Also, a zip code is talking about a location. So that's a quality. Where is somebody located? A phone number links to somebody, so that's a quality of that person, their phone number. So quantitative data are values that can be counted or measured, and the values will be numbers. So age, height, weight, pay per hour, temperature. Now if I take an age times another age, that'll give me another age. Temperature minus the temperature, that'll give me another temperature. So here the mathematical operations mean something. It makes sense to do. Okay, so there's two types of qualitative data. It can either be discrete data, which means you can count it, or it's finite, so there's limited possible choices. So for example, if you're talking about a dog having puppies, well then you can't say that the dog had 2.5 puppies. It's either 2 or it's 3. I can count 1, 2, 3. Okay? Continuous data, it's infinite. It keeps on going forever. So it may take on every possible value between any two values. So say we've got 11 and we'll go to 12. Say we're getting really close to 12. We can have 11.9 or 11.99 or 11.999. You see where I'm going? We can keep doing this forever. Okay, or an infinite amount of times. So basically, if there's any type of measurement, you can go right ahead and say, okay, well, that's going to be continuous. Since it's continuous, that is quantitative data. Because quantitative data will break down to discrete or continuous, but qualitative data doesn't break down to anything. It's just qualitative. Okay? Qualitative or quantitative. Sizes of soft drinks sold by a fast food restaurant. Small, medium, or large. Well, since it's breaking it down into a small, a medium, or a large into those categories, then that's going to be qualitative data. Number of degrees awarded by a college each year for the last 10 years. Okay, so number of degrees awarded. So since that tells you it's a number, that's going to be quantitative data. Ratings of teachers. So think of it as it's usually good, okay, or bad. Or it could be like 1 star, 2 star, 3 star, or 4 star, or 5 star. Those are still, you're putting that teacher in a type of category. So this would have to be qualitative. Grams of carbohydrates in a donut. Okay, so we're measuring the grams. Since we're measuring it, that's going to be quantitative. By the way, we can break down quantitative into either continuous or discrete. If we go back to this one, number of degrees, I can count how many degrees were awarded. So this would be discrete. Here, if I'm measuring grams, since it's a measurement, remember that is always going to be continuous. Okay, number on a football player's jersey. Now careful with this one, just because it says, okay, number. It's not actually counting how many football players. It's talking about the number that's on the jersey, so that's a quality of that person. So that's got to be qualitative. Okay, number of days during the past week a college student studied. Okay, I can count how many days that college student studied, so that would be quantitative. And since I can count how many days there were, discrete. Okay, assess value of a house. Well, it could be something like that, or it could be something like that. Okay, we could list out the numbers. The numbers would actually go on for if you list out every single possible number that there could be. So this, get rid of this. This is going to be quantitative, since you're talking about it's going to be a number of the house, and the mathematical operations of those would mean something. Assessed value of a house plus another assessed value of a house would be another assessed value of a different house. Now, whether it's continuous or discrete, since you can list out every single possible value that it could be, and since you're only dealing with two decimals, like 105, say, and a penny, okay, you could list out 2 pennies, 3 pennies, and you can list out all of these. So I would say that this is discrete because you could list them all out. There would be a ton of them, but you could list them all out. It's not infinite. Okay, student ID number, that is linked to a person, so it is a quality of that person. The model of car last sold by a particular car salesman. Okay, so the model, that would be a category, so that would be qualitative. Okay, discrete or continuous, and because I'm asking this, is it qualitative or quantitative? Quantitative, because quantitative breaks down into discrete or continuous, qualitative does not. Okay, the amount of caffeine in a cup of Starbucks coffee, we're measuring the amount of caffeine, so that's got to be continuous. The time it takes for the next text message to be delivered, okay, measuring time, that is continuous. The number of patients who reported that a new drug had relieved their pain, the number, I can count how many patients, discrete. The number of phone calls received by 911 phone center each day, okay, I can count how many, that's discrete. The length in minutes of a country song, okay, I'm measuring the length of the minutes. Measurement, that's continuous. The size of a shoe, okay, I'm measuring the size of a shoe, so that's got to be continuous. Okay, and then we're going to look at different sampling techniques. You've got simple random sampling, convenient sampling, systematic sampling, stratified sampling, and clustered sampling. Also put in one more here. It's called just random sampling, which is very closely related to simple random sampling, and I'll tell you the difference here in a second. Okay, remember, if you have a random sample, that gets rid of the bias within your sampling. So it makes your sample more representative of the population, which is what you want. Okay, simple random sampling, each group of size n, so you choose how big the group is. Here they chose n to be 4. So each group of size n has an equal chance of being selected. Okay, so here's my population right here, and they're going to randomly choose 4 people. So notice how they numbered everybody from 1 up to 15. So what they did was used a random number generator, which you can Google. There'll be a ton of them. And they said, out of 1 to 15, please give me 4 random numbers. And it gave a 3, a 2, a 10, and a 14. So this would be their sample right here. Now, every single combination of 4 people within this population had an equal chance of being selected. It could have been this person, this person, this person, this person. Or it could have been this person, this person, this person, this person. Okay? Every single group that you could possibly make with this population of 4 in a group had an equal chance of being selected. That is simple random sampling. Now, if it was just random sampling, then that is each person has an equal chance of being selected. So random sampling, each person, simple random sampling, each group of size, whatever you choose. Okay, convenient sampling. Okay, uses results that are easy or convenient to get. These samples are not random. A really good example is a voluntary response sample. So since it's not random, that means that there's bias in your sample. Now if you notice over here, so here's your researcher, and he's just going to ask the people that are closest to him. So notice each of the colors, so green is one characteristic, blue is another characteristic, and purple is a different characteristic. So what is missing here? If this is your population, does this sample represent this population very well? Well, no, because you're missing this characteristic right here. You don't have any of the purple characteristic within your sample. So this sample will not represent this population very well because you're missing this characteristic. Because it was a convenience to get that sampling, so you missed out on a particular characteristic there. And also, voluntary response samples, the reason why those are convenient sampling is all you have to do is post it to YouTube or to Facebook, and people say, yeah, I want to answer this, or no, I don't want to answer this. And the people who say no, they don't want to answer this, have a certain characteristic that is different from the people who do say, yeah, I will answer this. So since they didn't answer and they have a different characteristic, well then you are missing out on that characteristic within your sample. And since you're using that sample of all the people who said yes and they have a different characteristic from people who said no, to relate that back to the entire population, well then it's not going to represent your population because you're missing out on that particular characteristic of the people who said, nah, I don't want to answer this. Okay, systematic sampling. Select some starting point, then select every kth, just put a number in there, every 5th, every 10th, every 12th, every 100th element in the population. Must put the population in some order first. So if we're talking about people, we can put them in order based on last name, or height, or weight, or age. Okay? Something like that. You just have to put them in some kind of order. And once you say, you can start anywhere, you could start right here and say, okay, I'm going to go every other person. But they chose to start right here. And then this person, this person, this person. So 1, 2, 3, 1, 2, 3. So they went every third person here. Okay? Then stratified sampling. This one is going to break the population up into subgroups. You call them strata based on a characteristic, and this is important because stratified sampling is closely related to something called cluster sampling. So stratified sampling is based on a characteristic, and then it takes a sample from each of the subgroup. So here's my population. Say that this is Democrats, Republican, and Independent. So you break them up based on their party affiliation, and then you take a sample from each one of them. So this kind of makes sure that you have all the characteristics from your population. It's going to guarantee that it's also in your sample.